All right, welcome back. We graphed f of x equals x squared and negative x squared, which we got the picture here. And now we want to graph 2 times x squared. This is a new rule, okay? What this new rule does is that we have an input and x squared times x, of course we get x squared, and we're gonna double x squared, so we get 2 times x squared. So this rule simply is just going to be input and 2 times x squared. So we're going to graph this new function 2x squared. If we still use the same input, we will see that for -2, we have a 2 times the output we have there, 4, and it double that becomes 8. So for input and -2, under the new rule, the output is going to be 8. For the input of -1, we're going to double the output from x squared and multiply by 2, we're going to get 2. So for input and -1, we get 2. 0 stay the same. 1, the output is doubled. The output for x squared is doubled. And the output for 2, input 2, and the output is doubled. From 4, double becomes 8. So we get these points. Okay, so next I would like you guys to try to put the points in place. Put the points in the graph with me. Okay, so we're going to do 1 point at a time. 0, 0 stay in the same place. We're going to use green. And -2, 8. -1, 2. More points. 1, 2. 2, 8. We're going to see all these green dots. We're going to see all these green dots for 2x squared. 2x squared. Okay, the input stay the same. Input stay the same. The output is higher. The output is higher. So when we connect the dots, we're going to get the green curve, which is more narrow, which become more narrow than x squared, Okay, and next we're going to see half x squared. Okay, so I'm going to bring this table over here. Half x squared. Okay, half x squared meaning that the output for x squared is being halved, right? The input of -2, the output was 4 for x, under the rule of x squared. Under the new rule of half x squared, is half of 4 is 2. So for -2, output is 2. For -1, the output was 1 for x squared. Under the new rule, which is half x squared, it becomes half. And so for 0, 0 stay the same place. And we're going to plot all of these points. Okay, so here what I'm going to do is I'm going to take this picture. I'm going to draw the picture right here. And we're going to put all the dots over here. Okay, we're going to put all of these dots for half x squared in place. Okay, so we're gonna see what we get. We're gonna see what we get. Okay, so please, you also take your time to plot these points. Okay, so for -2, it was 4, now it's halved. And this time we're going to use the color blue. For -1, under the rule of x squared, it was 1, and now halved. That's the new rule, half x squared. And of course, 0, 0 stay the same. Okay, and for input 1, the output is half, because we have half x squared. And last but not least, on the table, and we have 2, and the output is 2 as well. So we have all these dots, and wait. What did I do? Okay, the blue here. Ah, I should put the dots. My bad. Point, point, point. There we go. So you're going to see the blue dots. You see the blue dots, right? So the blue dots, if we're connecting them, you see the green dots, which is 2x squared, is more narrow. The blue dots, however, is wider. So if we connect these blue dots, we will have half x squared, cursor squared, okay, and the blue. Where's our blue? There, curve. Okay, so to clarify, we summarize that this will be 2 times x squared. 2 times x squared. And the blue is half x squared. How about the red? The red is a negative x squared. Okay, so this is the situation when we have all of them together. Okay, so let's have all of them together. So you're going to see the picture with all of them together. Here we go. Okay, so this picture summarize the phenomena that we just observed. Okay, they're marked on the picture, but I'm going to just mark it one more time. So here, of course, this is x squared. And the green, that's 2 times x squared. More narrow, because the output is more, twice of the previous output. And the blue is half x squared. And of course, we all know the red. The red is negative x squared. All right, so this is the picture of, you know, based on x squared, when we multiply, when we double the x squared, when the rule is changed, become double, then the curve is more narrow. And if we have the x squared, we're going to have a wider. When we put a negative sign in front of it, it becomes opposite. So let's look at the domain and range. Let's look at the domain and range. Obviously, the domain for x squared is all real numbers. And all of these functions, actually, their domains are all the same. They're all real numbers. Okay, so I'm going to clean this up. Clean all drawings. Let's work on the domain and range. Okay, the domain and range. And all three, okay, x squared, 2x squared, and half x squared, they have the same domain and range. The same domain and range, right? From the picture, we can see that clearly. How about negative x squared? Well, for negative x squared, the domain is the same, but the range is different. Okay, the range is different. So let's summarize about their domain and range. I'm going to put a little table here. Four rows. Maybe just 3 columns. Okay, so the domain for x squared. Let me insert a row above. Okay, so this is the function. Okay, or rule, right? You can call them a rule. These are rules. And the domain. And that's the range. Okay, for x squared, the domain is from negative infinity to positive infinity. All of them are the same. Okay, and for 2x squared, domain is the same. For half x squared, domain and range are the same. Oops. Okay, so let me just adjust this a little bit. Okay, and negative x squared. Negative x squared. They have the same domain and range. X squared, that's greater than or equal to 0. And the 2 times x squared, of course, is still greater than or equal to 0. They're greater than or equal to 0. Okay, or you can say, you can use interval notation to show that. Okay, it's from 0 to positive infinity. Okay, from 0 to positive infinity for 2x squared. For half x squared, you know, it's the same thing. It's greater than equals to 0 still. And, or you can say, or it's greater, it's, you know, on the interval notation, you can use interval notation, which is from 0 to infinity. However, for negative x squared, the range will be changed. Okay, because if x squared is greater than equal to 0, negative x squared would be less than or equal to 0 because there's a negative sign in front of it. Or in other words, as we see from the picture, okay, that interval notation would be from negative infinity to positive 0. I'm sorry, not positive 0, to 0, from negative infinity to 0. Okay, so this is the summary of all these pictures and their domain and range. And next time we're going to talk about the shifting, horizontal shifting and vertical shifting of x squared.